Welcome to Introduction to Building Codes, Bangladesh National Building Code 2020, referred to as BNBC 2020. Part 8 Building Services, Chapter 6 Sanitary Drainage, Part 1 Sanitary Drainage Requirements. The description of this seminar is designed to familiarize and assist code officials, architects, engineers, and building owners in locating, describing, and applying the applicable code requirements for sanitary drainage requirements. An overview of the course. Internationally, code officials recognize the need for a modern, up-to-date plumbing code that addresses the design and installation of plumbing systems through requirements emphasizing performance. This presentation will cover key topics of the following areas: purpose and scope, terminology, permits, drainage and sanitation plans, licensing of plumber, drainage and sanitation requirement, materials and appliances, hangers and support, and finally, design considerations. Our seminar goal is for you to learn and apply key code requirements contained in Chapter 6, Sanitary Drainage, to enhance your performance while inspecting these systems. This training will also provide participants with specific code requirements, with examples related to design, installation, and inspections of sanitary drainage systems to further enhance your knowledge. Our course objectives are as follows. Upon completion, participants will be better able to locate general topics in Chapter 6 Sanitary Drainage, locate applicable codes and standards for specific situations, apply code requirements to real-world situations, as well as explain the intent behind a given code requirement, and finally use good judgment to identify certain systems and related components as compliant or non-compliant. We utilize the code as a guide for not only the design basis of a system regarding sanitary drainage and venting, but also the installation requirements for a safe system for the end user. Sanitary drainage. Some general information is indicated here. The purpose of Chapter 6 is to regulate the materials, design, and installation of sanitary drainage piping systems, as well as the connections made to the system. Now, this could be the drainage piping that carries the wet portion of the discharge, as well as the venting portion, which provides an atmospheric pressure into the system as well. The intent is to design and install sanitary drainage systems that will function reliably, are neither undersized nor oversized, and are constructed from materials, fittings, and connections whose quality is regulated by this section. Plumbing fixtures installed in a building or structure must connect to a sanitary drainage piping system, and that system must connect to a public sewer system or private disposal system. The conventional method of sizing a sanitary drainage system is by drainage fixture units, abbreviated DFU. These are load values. The drainage fixture unit approach takes into consideration the probability of a load on a drainage system. The drainage fixture units allow us to properly estimate the capacity of pipes that are constructed for our drainage system. Section 6.1 is titled Purpose and Scope. The purpose of this chapter of the code is to provide requirements and minimum standards for the planning, design, and installation of waste disposal systems in and out of buildings. The authority has the responsibility for administering the code to ensure that waste disposal systems in homes and the buildings in which people live and work are designed, installed, inspected, and tested to provide acceptable waste disposal functions. Additionally, the proper design and installation of waste disposal systems, according to Chapter 6, provides a level of protection regarding health, safety, property, and public welfare. This initial section of the code gives the authority that ultimate responsibility for administering this code to ensure public safety. Section 6.2 is titled Scope. This section gives us the requirements whether the application fits this code or not. When we look into section 6.2.1, it indicates the following. This chapter specifies the general requirements for environmental sanitation for different categories of buildings according to their occupancy classification. We further look on to the next section, which is section 6.2.2. This chapter also covers the design, installation, and maintenance of drainage systems together with all ancillary works such as manholes and inspection chambers used within the building and from the building to public sewers or to off-site waste disposal systems. In other words, into septic systems and seepage pits or subsurface drainage systems. Finally, Section 6.2.3 tells us that the disposal of waste from industries, nuclear plants, slaughterhouses, etc., are not covered by this code. These wastes shall be properly treated as specified by environmental quality standards of Bangladesh before their disposal into public sewers or into natural bodies of water. The summation of these three sections give us the requirements set forth to scope our applications. It tells us in the beginning of the code that this chapter contains general requirements for environmental sanitation for different types of buildings that we will look at according to their occupancy classification. It also covers the design and installation and maintenance of these drainage systems, as well as the omission of industries, nuclear plants, slaughterhouses, etc., are not covered by this code. So this section gives us the driving language to understand when we are in the code or out of the code with respect to our applications. Section 6.3 is titled Terminology. This section provides an alphabetical list of all terms used and applicable to this chapter of the code. In case of any conflict or contradiction between a definition given in this section and that in any other chapter or part of the code, the meaning specified in this chapter shall govern for interpretation of the provisions of this chapter. This spells out clearly that the terminology contained within this section is very specific to our study today on sanitary drainage systems. The terminology actually has a specific meaning and shall govern the interpretation accordingly. A code provision could be misinterpreted if the definition of a term, as used in the context of this code, is not understood. The following slides will provide key definitions that will assist the code user to properly understand certain terminology related to this chapter. Codes, by their very nature, are technical documents. As such, literally every word, term, and punctuation mark can add to or change the meaning of the intended result. This chapter contains several terms that are important to understand the provisions of this code. Definitions are found both in this chapter and throughout the code. So let's look at some key terminology. Branch is defined as any part of the piping system other than a main, riser, or stack. Drainage system gives us a specific definition. A drainage system includes all of the piping within public or private premises, which conveys sewage, rainwater, or other liquid waste to a legal point of disposal, but does not include the mains of a public sewer system or a private or public sewage treatment or disposal plant. We have a drawing indicating a drainage system and components. The example of drainage system conveying waste from fixtures to the sanitary building drain, then to the sanitary building sewer. Looking at the drawing, we can observe the sanitary building drain within the building below the second floor level. This is the location that conveys the discharge from all of the fixtures connected above. The piping is sloped downward and conveyed to the outside of the building into the sanitary building sewer. As can be seen as well, we have what's called a building subdrain, in which condition the lavatory, the shower, and the water closet below the slab floor level in the lower level of the building conveys all of the discharge to a gas-tight sump. In this case, the discharge is pumped from this sump through a check valve and a full open valve and discharges it into the sanitary building drain, and then by gravity it flows through the building drain and conveys that discharge into the building sewer. Branch interval. The length of soil or waste stack corresponding in general to a story height, but in no case less than 2.5 meters, within which the horizontal branches from one floor or story of a building are connected to the stack. One branch interval corresponds to a length of drainage stack that has two horizontal branch connections at least 2.5 meters apart. As seen in the graphic to the right, we have two different floor levels. Based upon these two different floor levels, we are concerned whether the piping arrangement indicated on both sides of the soil or the waste stack is considered a branch interval. To the right-hand side of the soil or waste stack, we can see that the measurement from the horizontal drainage pipe below floor level 1, the soil or waste stack rises, in this case, 2.5 meters or more to the next horizontal drainage pipe tied to the soil or waste stack. When this happens, this is considered a branch interval. Again, meeting the definition. In no case less than 2.5 meters. So the distance is a function of how the drainage system will work and be loaded up in the system, as we will find out later in our design examples. To the right side, we indicate that this is a branch interval. If we look to the left-hand side of the soil or waste stack, we see that the elevation from floor level 1 to floor level 2, the upper floor, has a 3-meter story height. Therefore, if we have any connections, as we do here, we have 2 horizontal connections into the soil stack on the left-hand side. The vertical distance measured is 1.3 meters between these horizontal connections into the soil or waste stack. This is not considered a branch interval. Does not meet the definition. As we recall, it must in no case be less than 2.5 meters. In typical multi-story construction practice, typically with 2.5 meter ceilings, horizontal branches connect just below each floor level to a vertical stack. Branch intervals are a design factor for drainage pipe sizing and venting. Drain, waste, and vent system design must consider the nature of waste, airflow in a stack, and the effects that branch connections have on such a flow. The branch intervals are a design factor, of course, and we need to understand exactly where they occur in the systems. Fixture branch is defined as water supply pipe between the fixture supply pipe and the water distribution pipe. As you can see in the graphic below, which indicates a drawing of 3 different types of plumbing systems, we will focus on the water main outside of the building on the left-hand side of the building indicated. From the water main, the water service pipe comes into the building through valves and a meter, and then it rises up as a water supply pipe or water distribution pipe to the fixture branch, which is located at the top floor of this particular building. This way we can see exactly how the definition is applied in our industry. The next definition is fixture supply. The water supply pipe connecting the fixture with the fixture branch. Now, if the pipe was actually connected to a fixture indicated on this drawing, we would see the fixture. Maybe this branch connects to a lavatory or a sink or a water closet. That would be the supply pipe that connects with the fixture accordingly. The definition of plumbing system is very specific and detailed. Plumbing system is defined as a system of potable water supply and distribution pipes, plumbing fixtures and traps, soil waste and vents, and sanitary storm sewers and building drains, including their respective connections, devices, and appurtenances within a building or premises. Again, referring to the drawing above, the plumbing system is very specific. As shown in this drawing, we have three separate plumbing systems. We have our water supply system. We have our sewer system, which conveys the building drainage within the building to the public sewer or main sewer indicated on the left-hand side of the drawing. On the right-hand side of the drawing, we'll start up at the top of the building with our roof drain. Our roof drain collects water that's known as storm water from rain. It then conveys the water down what we call a vertical pipe known as a conductor. It brings it down into the building storm drainage system and conveys it outside of the building into the building storm sewer. As indicated below the building on this particular storm system, we have a sump, and the sump is actually collecting water from the subsoil drainage system shown outside of the building. As you can see, the pipe that connects from the subsoil drain system around the building is piped into the sump, which is a catchment area. From that point, there is normally a submersible pump within the sump that allows the water to be lifted above and connected into the building storm drain and then drained by gravity outside of the building to the building storm sewer. So these are our three piping systems, better known as the entire plumbing system. The term building drain gives us an identification of what this particular segment of the building drainage system is. It is defined as the building drain is that part of the lowest piping or open channel of a drainage system, which receives the discharges from soil, waste, and other drainage systems inside the walls of the building and conveys the same to the building sewer, beginning at 0.9 meters outside of the building wall. As you can see, the graphic at the bottom of the slide indicates the building drain as being the lowest piping indicated within the building. It then extends 0.9 meters from the outside of the building wall. That is where the building drain ends. From that point, the next part of the piping system is titled building sewer. The building sewer connects from the end of the building drain and ties into the sewer main in the case of this graphic. By definition, the building sewer is as follows. The building sewer is that part of the horizontal piping of a drainage system which extends from the end of the building drain and which receives the discharge of the building drain and conveys it to a public sewer, a private sewer, individual sewage disposal system, or other point of disposal. This is also known as sewer. Lastly, the term public sewer. This is a common sewer directly controlled by public authority, also known as main sewer. As you can see, definitions are very specific, and in this case, it lays out the demarcation of where one system begins, one system ends, and the connection between the two distinct systems. The terminology for horizontal branch helps us understand the specific function of this component. A horizontal branch is a drain pipe extending laterally from a soil or waste stack or building drain, with or without vertical sections or branches, which receives the discharge from one or more fixture drains and conducts it to the soil or waste stack or to the building drain. As indicated in the drawing below, we have a soil stack rising vertically from below and the connection of our horizontal branch into the soil stack. What is discharged into the horizontal branch is a washing machine standpipe, a laundry tub, and a kitchen sink. These are the fixtures that are discharged downward and enter into the horizontal branch that conveys the discharge and connects to the soil stack. Plumbing system is defined as a system of potable water supply and distribution pipes, plumbing fixtures and traps, soil waste and vent pipes, and sanitary and storm sewers, and building drains including their respective connections, devices, and appurtenances within a building or premises. Graphically, we can look at the plumbing system as a series of multiple systems. If we focus on the sanitary drainage portion of the plumbing system, in the lower left-hand side of the drawing, we start out with the public sewer or the main sewer. We have a pipe that is called the building sewer that attaches to the building drain pipe. This receives all of the waste at its lowest level, called the building drain, as we understand according to the previous definition. As we rise up on the building drainage system, we move up to different floor levels. As we move up to floor levels, the stack rises vertically. We have horizontal branches, or a branch in this case, that connects into the stack. As you can see, the dark solid line represents the wet portion of the piping system. Therefore, the stack rises up vertically and turns into what we call a stack vent. This is a typical look at the drainage portion of the plumbing system. Fixture unit. A fixture unit is a quantity in terms of which the load-producing effects on the plumbing system of different kinds of plumbing fixtures are expressed on some arbitrarily chosen scale. That arbitrarily chosen scale, however, is somewhat well-defined based upon probability. The conventional method of designing a sanitary drainage system is based on what we call drainage fixture unit load values, abbreviated DFU, or simply fixture units can be used to define this particular loading probability. The fixture unit approach takes into consideration the probability of load on a drainage system. Just like any system, we're concerned with respect to the demand of the system. Once we understand the demand of the system or certain parts of the system, we can understand and apply and analyze piping sizes for different parts of the system as a basis of design. The DFU is an arbitrarily used loading factor assigned to each fixture relative to its impact on the drainage system. To further understand this value, we look at the DFU values determined based upon the following: average rate of discharge by a fixture, the duration of a single operation, and the frequency of use or interval between each operation. This is what goes into the fixture unit number, are these particular factors. Horizontal pipe is defined as any pipe or fitting which is installed in a horizontal position or which makes an angle of less than 45 degrees with the horizontal. When we look at the drawing below, we can see a pipe designed as a horizontal branch or horizontal branch drain. Looking at this particular pipe, we can verify that this is properly defined as a horizontal pipe according to the definition. A vertical pipe is any pipe which is installed in a vertical position or which makes an angle of not more than 45 degrees with the vertical. Again, looking at our drawing, we have a pipe called a water riser. We can see the water riser is a vertical pipe, as well as the stack indicated on the left-hand side of the drawing. The stack and the stack vent, which rises above the stack, are vertical pipes, and they meet the definition accordingly. Section 6.4, Drainage and Sanitation Plans. Specifically, Section 6.4.1 gives a requirement of permit. Drainage and sanitation systems shall not be installed until a permit for such work has been issued by the authority. For existing, this is only for addition and for alteration, or new building or for other premises. Section 6.4.2, Application for Permit. An application for a permit for drainage and sanitation work shall be made on a prescribed form by the licensed plumber and the owner, or by his appointed person or agent to install or a self-contained workable part of such work. This section contains the requirements for the issuance of drainage and sanitation permits. It also establishes how and by whom the application for a plumbing permit is to be made, how it is to be processed, and what information it must contain or have attached to it. As you can see in section 6.4.2, there is a reference to see Appendix Q. This will be a prescribed form for the application for permit. Appendix Q contains a prescribed form regarding information required to construct the drainage and sanitation system. The application for a permit shall be made on a prescribed form by the licensed plumber and the owner, or by his appointed person. So as an indication, the application is shown here. And the information that is required on the application is itemized. Item number 1 requires the occupancy classification. Item number 2 requires the number of stories within the building. Number 3, the plumber needs to provide the location. And number 4 is very specific as it references certain code sections. Item number 4 indicates this application is accompanied by all required plans, drawings, and the drawings must show details of materials, must show sizes, gradient, and location of pipes and fixtures, and other details as specified in the following sections: 6.4.2, 6.4.3, 6.4.4, and 7.5.2 of Part 8 of the Bangladesh National Building Code. And additionally, the signature of the plumber is required, as well as the signature of the owner or the owner's appointed person. Additionally, name and address is required for the plumber and the owner or the appointed person by the owner. Section 6.4.2, application for permit. This is a continuation. The application shall accompany the building drainage plans, an adequate description of the proposed drainage and sanitation installation in a drawing with the following details. Now, as noted in parentheses, drawn to a scale not less than 1 in 100. Item A indicates one of the following details: plans of the building with typical arrangement of plumbing fixtures. This is important because the authority needs to see the arrangement of plumbing fixtures, where they will be located. Item B, details of the sanitary waste disposal system. Details being materials and piping, things of that nature. C, venting system in the building drainage system. D gets more specific here with respect to materials, sizes, and gradients of all proposed piping. E is the position of manhole, traps, waste pipe, any rainwater pipe, vent pipe, water closet, urinal, lavatory, sink, or other appliances in the premises, and their connection with sewerage, drainage system, or with private waste disposal system. The following colors may be used to indicate the following: sewers, wastewater pipes, and rainwater pipes, and existing works. A red color is utilized or may be utilized as the color for proposed sanitary sewers and sanitary waste disposal pipes. The color blue may be used for wastewater pipes, rainwater pipes. An existing network can or may utilize a black color. Finally, item F, position of refuse chute, inlet hopper, and collection chamber for high-rise buildings. In summation, the design drawings and calculations and other submittal documents for the building drainage system must accompany the permit application and be of sufficient detail and clarity to verify compliance with the code. As seen above, each item is very specific in what needs to be submitted along with the application. An example of design plans for a building drainage system is shown below. Observe the routing and the sizing of the drain and vent piping systems. By inspection, we can see the sanitary drainage pipes at the far right-hand side of the drawing. These are the main arteries that discharge from branches of the building drain. The dark colored lines are the wet portion of the drainage system. And if we look to the leftmost portion of the drawing, we can see that the water closet indicated WC-H is indicated accordingly. The pipe sizes are indicated as well, as far as the fixture drain from the water closet -H is indicated at 100 millimeters, and the arrangement or the routing of the piping is also shown to come downward, flowing into the sanitary drainage system, as well as the lav, which is the sink for the bathroom. Lav-H is indicated as flowing downward and entering into that section of the horizontal drain, and the pipe size indicated as 100 millimeters. As well as the venting can be seen here. The venting is the dashed line. The dashed line comes off of fixtures that are individually vented, and the vent piping sizes are indicated all the way throughout the system. This gives a good routing, a good location and arrangement of where the plumbing fixtures need to be, along with the pipe sizes accordingly. The only thing that we don't really see here are the proposed gradients or the grades or the slope of the pipes, as well as the materials of the pipes. Section 6.4.3. In addition to a drainage plan, a separate site plan of the building shall be submitted with the following particulars. In item A, any adjoining plots and streets with their identification must be shown and documented on the plan. Item B, position and invert level of public sewers, if there are any, and the direction of flow in that public sewer. Item C, level of proposed drains connecting to the sewers. Item D, position and layout of private waste disposal system. This is in the absence of public sewers. And finally, item E, alignment, size, and gradients of all drains. These items must be submitted along with the building construction documents for the sanitary drainage systems. A more specific section is given to us for high-rise buildings in section 6.4.4. For high-rise buildings, design calculations and specifications for various systems of the work involved shall be submitted along with the drawings. As seen on the right-hand side of the slide is a typical site plan that would need to be prepared for the authority to review regarding the sewer and drainage layout and all gradients and pipe sizes accordingly. Section 6.4.5 is related to permits and approvals. The building official shall examine or cause to be examined all applications for permits and amendments thereto within 45 days. If the application does not conform to the requirements of all pertinent laws, such application shall be rejected in writing, stating the reasons therefor. If the proposed work satisfies all code requirements, the authority shall issue a non-transferable permit. Now, this section requires the code official to review or cause the review of all submittals for a permit. Reviewing is compliance with the code, and the code official is to verify that the project will be carried out in accordance with any other applicable laws. A detailed review of plans and specifications is, of course, necessary to verify that the design complies with the code, thereby avoiding costly modifications during the course of the installation. This is very important, and the authority, as seen in the section above, needs to provide this within 45 days. Section 6.5 is licensing of plumbers. Specifically, Section 6.5.1 indicates no individual, partnership, corporation, or firm shall engage in the business of installation, repair, alteration, or maintenance of plumbing, drainage, and sanitation work without obtaining a license from the authority. This section mandates that the plumbing work must only be executed by a qualified plumber. Licensure of qualified plumbers is a requirement in this section for installation, repair, or alteration of plumbing, drainage, and sanitation systems. Plumbing work shall be executed only by a licensed plumber under the control of the authority, and shall be responsible to carry out all lawful directions given by the authority. This section mandates the importance of having qualified people install the drainage system in accordance with this code. Section 6.5.2 is titled Examination and Certification. Now, in this section, the authority establishes a plumber's examination board. The board will determine the requirements for qualification and procedures for examination of applicants for license. The authority will issue the license to such applicants who meet the qualifications therefor and successfully pass the examination conducted by the board. In order to qualify as a licensed plumber, the authority establishes an examination board first. Qualified individuals must be qualified by meeting academic, vocational, and experience requirements, as may be set up by this particular board. Additionally, they must complete and pass an examination. This whole process ensures the safety of people by allowing only qualified people to install, repair, and alter drainage and sanitation systems. However, we have Section 6.5.3, Annulment of License, which states the license of a licensed plumber may be nullified by the authority if it is proved that a plumbing work has been completed and certified by the licensed plumber, violating the provisions of this code deliberately, setting aside the approvals given in the permit, or without receiving the permit from the authority. So this last section indicates that there are certain areas that the authority is permitted to nullify the license from the licensed plumber if they violate any provisions of this code. Regarding single-family dwelling units, Section 6.6.1 gives us some general information. Item A, each family dwelling unit on premises abutting a public sewer or with a private waste disposal system shall have at least one water closet and one kitchen sink or washing facilities. This is very specific in the amount that must be installed in the family dwelling unit. It is recommended to have at least one bathroom with a bathtub or shower to meet the basic requirements of sanitation and personal hygiene. And in that case, bath and water closets shall be separately accommodated. Each family dwelling unit must have at least one water closet and one kitchen sink or washing facilities as indicated. Below we have the Indian type water closet, the European type water closet, and an example of a kitchen sink. All three are fixtures that are recommended and required in this particular section. This deals with personal hygiene, the requirements of a water closet, and one kitchen sink or washing facility is mandated specifically in this section, and as well as a bathtub or shower within the bathroom. Continuing with section 6.6.1, item B, all other structures for human occupancy or use on premises abutting a sewer or with a private waste disposal system shall have adequate sanitary facilities, but in no case less than one water closet and one other fixture for cleaning purposes. Very specific here. Item C, there shall be one water tap, an arrangement for drainage in the vicinity of each water closet in all buildings. And item D indicates there shall be at least one water tap and arrangement for drainage in the vicinity of each urinal or group of urinals in all buildings. The picture below indicates a group of urinals. We have, in fact, a basin with a water tap indicated for the use adjacent to the urinals or the group of urinals indicated. Item E, there shall be separate facilities for each sex for public toilets and for public bathing places based on the percentage of each anticipated sex. Item F, where drinking water fountain is provided, it shall not be installed in toilet room. This is a very specific requirement. This is an unsanitary condition by having a drinking water fountain installed in a toilet room, and item F prohibits this installation specifically. Item G, rooms containing water closets or urinals shall be separated by partition wall from places where food will be prepared and served. Indicated below on the drawing is a kitchen area where food is being prepared. We have two toilet compartments as seen with the doors opening into the kitchen. Item G will prohibit this. The doors must open outward out of the kitchen area. As indicated, any types of rooms containing water closets need to be separated by partition walls, and that does not comply as indicated. Item H, all water closets and urinals shall be provided with flushing system. The minimum number of fixtures is given by requirement in Section 6.6.2. Table 8.6.1, Sections 6.6.2.1 and 6.6.2.2 provide the minimum number of fixtures required for different categories of buildings according to their occupancy classifications. The fixture requirements for the occupancy not provided in these sections shall be subject to the approval of the authority, meaning that this section requires that the type and number of plumbing fixtures based on the actual use of the building or the space and the occupant load as determined by the building code. If there are occupancies that are not provided in these particular sections, the authority must evaluate the application and make a ruling on the number of fixtures for those particular applications that are not indicated in these code sections. Table 8.6.1 titled Plumbing Fixtures Requirement. This is a partial view of that particular table. Discussion of the table is as follows. In the first column, titled Type of Building Occupancy, this gives us, in the first row, a E-business with categories E1 for offices, E2 for research and testing laboratories, and E3 for essential services. The category E business also gives us the water closets and the wash basins and the ratios for distribution for the number of males and females accordingly. The next column, the middle column, bathtubs or shower. In certain occupancies, bathtubs and showers are required, but as seen here in the E-business category, there are no requirements for bathtubs or showers. Urinals are given here for male in the ratio shown in this particular column. Drinking fountains, the next column, are indicated for E-business in all areas of the businesses, E1, E2, and E3, at a ratio of 1 drinking fountain per 100 occupants. And finally, the last column, other fixtures, gives requirements. In this case, in the E-business category, service sink is required at 1 per floor. 1 per floor. Now, there are notes to the table. Notes to the table are a function of the table, specific functions when noted. The first asterisk, one single asterisk, indicates some of the water closets may be of European style. The water closet shall not be oriented in the east-west direction. 2 asterisk, note, the urinal shall not be oriented in the east-west direction. 3 asterisk, toilets of public use shall have at least 1 water tap with adequate drainage arrangement per ablution purposes when the number of devotees exceed 20. 4 asterisk, plumbing fixture requirements for occupancy M1 shall be assessed considering its nature of use and the similarity in purpose with any of the occupancies mentioned. These are specific notes to the table that the code user must follow when the notes are referenced. As an example, if we go to the top of the table in the second column, we see water closets with a single asterisk. We go to the notes of the table and read the note to the table. In this case, as we know, it states some of the water closets may be of European style. The water closets shall not be oriented in the east-west direction. An example given here references Table 8.6.1. Consider a single-floor office building with an occupancy classification E1, with an occupant load of 320 occupants. The plumbing designer received approval from the authority to substitute urinals for not more than 50% of the water closets required for the total male occupant load. This was an approval that was previously understood with the authority and the designer. What is the minimum number of fixtures required for all occupants? From the table above, we locate this particular part of the table in our code. The category is E, business. E1 is offices, so we find that in the first column. The first step is to calculate the number of male and female occupants. We simply take our total occupant load of 320 and divide that by 2. That equates to 160 male and 160 female occupants. The second step is to calculate the number of male water closets and urinals. To do this, we enter the table and obtain the ratio. In this case, the male ratio for water closets is 1 per 25 occupants. Knowing that ratio from Table 8.6.1, we simply take the male occupant load at 160 and divide by 25. And that equates to 6.4 or 7 required water closets. Now, based on the agreement with the plumbing designer and the authority, substitution of 3 urinals that is not more than 50% of the 7 water closets required, of course, will be substituted. Therefore, a total of 4 water closets will be provided and 3 urinals will be provided for the male occupant load. The female water closets, we apply the ratio given to us in the table. Water closet column, the female ratio for water closets is 1 water closet per 15 female occupants. Therefore, we take the female occupant load of 160 divided by 15 equals 10.7, or we specify 11 required water closets for the female occupant load. Next, we calculate the male wash basins. Back into the table, the third column indicates wash basins. For male and female, the ratio is the same. 1 wash basin per 25 male occupants and 1 wash basin per 25 female occupants. Therefore, for the male, we take the occupant load of 160 divided by 25 equals 6.4. We specify 7 male wash basins are required. And for the female, it's exactly the same due to the same ratio. We take 160 female occupants divided by 25 and that equates to a required 7 female wash basins. Next step, we apply drinking fountains. We apply a ratio of 1 to 100 from table 8.6.1. This is in the column labeled drinking fountains. We need 1 drinking fountain per 100 occupants. So from our total occupant load of 320, we simply divide by 100. That equates to 3.2, or we specify a minimum of 4 required drinking fountains for this particular occupancy. Last is our other fixtures indicated in the last column. We need 1 service sink per floor indicated in the table. So 1 sink is required per floor. However, our proposed building is only 1 floor. Therefore, only 1 service sink is required and will be specified by the engineer. This is a good example of how to apply the table accordingly and provide the minimum number of fixtures required. Another example of the category titled Assembly gives us the assembly characteristics for large assembly with fixed seats, I1, I2, small assembly with fixed seats, I3, large assembly without fixed seats, and I4, small assembly without fixed seats. For our mosques, water closets have a ratio of 1 per 30 occupants. Bathtubs or shower, 1 per 100. Drinking fountains, 1 per 100 occupants, and other fixtures in the very last column are indicated that we must supply water taps with drainage arrangement of 1 per 10 occupants. For junction stations, intermediate stations, terminal stations, and bus terminals, we have water closets and wash basin ratios as indicated for male and female. Urinals for male are given to us at a minimum of 2, 4 per 1,000, and then adding 1 per additional 1,000. Drinking fountains for this particular occupancy is 1 per 300 occupants. And then in the last column, other fixtures, we need a service sink, 1 per floor, for junction stations, intermediate stations, terminal stations, and bus terminals. And also keep in mind that the notes to the table apply when referenced. Section 6.6.2.3 provides us with floor drain requirements. Floor drains shall have removable strainers. The floor drain shall be constructed so that the drain is capable of being cleaned. Access shall be provided to the drain. The graphic on the left-hand side indicates a floor drain with a removable strainer. All strainers must have removable strainers. All floor drains must have removable strainers to enable cleaning of the drain, body, and rotting of the drain. That is the function of having the removable strainer. Additionally, floor drains may be required and installed where we have appliances such as water heaters, furnaces, air conditioning units, boilers that need to discharge their waste to certain floor drains. However, the floor drains require ready access and must not be located under appliances or equipment or shelving or within wall cavities or covered by objects that might obscure their location. They need to be accessible. Automatic clothes washers have a very specific waste connection. In section 6.6.2.2, the waste from an automatic clothes washer shall discharge through an air brake into a standpipe. The trap and fixture drain for an automatic clothes washer standpipe shall be a minimum of 50 millimeters in diameter. The standpipe, trap, and fixture drain for clothes washer must be a minimum of 50 millimeter in diameter. As shown in the photo to the right, we have a standpipe, that is the vertical pipe that extends downward from the drain of the clothes washer machine downward through the trap into the outlet of the trap into the drainage system. The diameter must be 50 millimeters. For the applications where an air brake is indicated, as this automatic clothes washer section requires, an air brake is simply braking the flood level elevation of the particular fixture with the drainage tube going down into the standpipe. For the applications, again, where an air brake is indicated, either there is no possibility of back siphonage condition occurring in the indirect waste pipe, or a contamination of the indirect waste pipe has no impact to the health of the building occupants, it can then and therefore be permitted. As such, in this case, being utilized as an air brake connection. Section 6.6.2.4 gives us the requirement in our code for physically handicapped plumbing facilities. All buildings other than residential, educational, storage, and hazardous, according to building occupancy classification, having public toilet facilities with required number of fixtures shall have at least one water closet for each sex and one drinking fountain accessible to and usable by physically handicapped persons. The water closet compartment for physically handicapped persons shall be in accordance with section 6.9.4. This section requires that certain public toilet facilities, as well as water closet contained within, are required to be constructed in such a manner that persons with physical disabilities will have access to those facilities in a manner similar to persons without disabilities. Now, these people can have disabilities in which they maneuver in wheelchairs, or maybe if they have canes or walkers. That would be the physical disabilities that we are talking about. Section 6.9.4 is referenced for the construction of water closet compartments for physically handicapped persons. A drinking fountain accessible to and usable by physically handicapped persons is also required to be provided. As an example, the water closet compartment for physically handicapped persons needs to be in accordance with this particular section, section 6.9.4. We reference this section titled Provision for Wheelchair Users. The water closet compartment for wheelchair users shall have at least the dimensions and fittings as shown in figure 8.6.4. This section provides technical requirements regarding minimum dimensions for the compartments, the water closets, support rails, and door width for wheelchair users to access and use the water closet fixture. As we look at this figure to the left, the top portion indicates a section view. Looking at it, we are noticing that there are certain dimensions given to us from finished floor all the way up to the top of the water closet, 450 millimeters. And from that point, an additional 250 millimeters to the required support rail that has to have a diameter of 32 millimeters. In plan view, the lower graphic indicates the door width being 800 millimeters in width. Once the wheelchair user enters the compartment dimensions are given accordingly on the height and the width, or the width and the length of the room properly stated. We have 32 millimeter diameter grab bars as the support rails, and we also have a dimension from the end of the grab bars to the edge of the water closet, being indicated here at 300 millimeters. These are the specific technical requirements for water closet compartments for provisions given to people in wheelchairs. The next part is indicated in section 6.9.4.2. This section gives provision for ambulant disabled people. The minimum dimension for water closet compartment and the fittings for ambulant disabled people shall be shown in figure 8.6.5. The purpose of the ambulatory stall is more to serve persons with mobility impairments who may be using a walker, a cane, or crutches in order to walk and mobilize. In an ambulatory stall, both grab bars are particularly used simultaneously for balance. This section provides technical requirements regarding minimum dimensions for compartments, water closets, support rails, and compartment width for ambulant disabled people. As we look at figure 8.6.5, we notice the plan view. The plan view is very clear in that it gives us the length and the width dimensions of the compartment, as well as the location of the grab bars or support rails as indicated. We also see the same dimension of 300 millimeters from the edge of the toilet to the edge of the particular length of the support rails. The section view indicated to the right gives us the same requirements as the water closet for disabled people in wheelchairs. In this, it is the same elevation above the finished floor, 450 millimeters to the top of the water closet, and then an additional 250 millimeters to the support rail accordingly. Accessibility requirements are also given to us in section 6.6.3 regarding the location of these accessible facilities. The fixtures specified in section 6.6.2 for public building shall be located not more than 1 floor above nor more than 1 floor below the floor occupied by the people for whose use the fixtures are intended, unless elevator service is available, except that in buildings which are accessible to the physically handicapped, there shall be a minimum facilities as specified by the code. It is desirable that the path of travel to the facility shall not exceed a travel distance of 150 meters. This is to prevent health problems for building occupants related to difficulty in accessing a needed toilet facility in a timely fashion. The code clearly provides 2 conditions that must be met. Number 1, the building occupant must not be required to travel beyond the next adjacent story above or below his or her location within the building. Number 2, the required toilet facilities must be located within 150 meters. As an example, if we have a building, as indicated below, and the most remote point that the occupant can be away from the toilet facilities is indicated here at a maximum travel distance not to exceed 150 meters to the toilet facilities. Section 6.7, Materials and Appliances. Different sanitary appliances, materials, and fittings shall conform to the requirements of the standards as provided in tables 8.6.3 of this chapter and table 8.5.9 of chapter 5, part 8. For other appliances, materials, and fittings that are not listed in the above-mentioned tables shall be subject to the approval of the authority. Table 8.6.3a is titled Recommended Standards for Sanitary Appliances. As we can see in the table, on the left-hand side of the table, under Appliances, it gives us specific appliances. The first one is ceramic wash basin and pedestals. The standard associated with that particular appliance is BDS 1162-87. This table allows the designers to specify appliances that are indicated in the table according to the associated standards. This is all for public safety and health for the end user. The standards are a series of requirements and testing and construction of these particular fixtures. In the right-hand portion of the table, we can see that there are more appliances, such as metal sinks for domestic purposes and the associated standards, urinals of the bowl type, vitreous china, wash-down water closet pans, again vitreous china, water closet seat, plastic, has the standard BS 1254, and finally water closet flushing cisterns and pipes and the associated standard BS 1125. Table 8.6.3b, titled Recommended Standards for Building Drainage and Vent Pipe. The materials are indicated on the left side of the table. Standards are indicated on the right side of the table. We have ABS plastic pipe and the associated standards. Aluminum tubing is a material that can be utilized for building drainage and vent pipe, as well as brass pipe, cast iron pipe, copper or copper alloy tubing. We have galvanized steel pipe that is permitted, and polyvinyl chloride plastic pipe, better known as PVC. As an example, Schedule 40 ABS plastic drain, waste, and vent pipe is and properly addressed as complying with the standard ASTM D2661 for that particular material. Again, Schedule 40 ABS plastic drain, waste, and vent pipe. Additionally, Schedule 40 PVC plastic drain, waste, and vent pipe must comply with the standard ASTM D2665. Table 8.6.3E, titled Recommended Standards for Joints Between Different Pipes and Fittings, allows us to locate materials and standards for different types of pipes and fittings accordingly. As an example, all of the materials are indicated in the left-hand portion of the table and the standards in the right-hand portion of the table. Again, we have an example of an ABS type of material. In this case, it's a plastic pipe fitting called a coupling. We also have PVC plastic pipe fittings and the associated standards. As indicated below, we have what's called a Sanitary T, and that is PVC plastic pipe material. So again, the designer can reference this particular table and specify pipe fittings and the associated standards for those particular fittings. Table 8.6.2, titled Sanitary Appliance Minimum Internal Diameter of Waste Outlet, gives us soil appliances and waste appliances. As noted, the table is essentially split in half. The soil appliances indicated in each line item. Item A indicates Indian and European type water closets must have a minimum internal diameter of 100 millimeters for the waste outlet. Item B, bedpan washers and slop sinks, again, must be at least 100 millimeter internal diameter. Urinals with integral traps are permitted to have 75 millimeter internal diameter, and stall urinals with not more than 50 to 120 millimeters of channel drainage must have a minimum internal diameter of 40 millimeters. And finally, lipped small urinals must have a minimum internal diameter of 40 millimeters. Those are our soil appliances. To the right, we have our waste appliances, such as drinking fountains, wash basins, bidets, domestic sinks and baths, shower bath trays, domestic bathtubs, hotel and canteen sinks, and finally, floor traps, which gives the outlet diameter of 65 millimeter at a minimum. So this table essentially identifies some common soil and waste appliances with their corresponding minimum internal diameter of waste outlets in millimeters. Section 6.9.5.2 gives us a requirement regarding the slope of horizontal drainage piping. Whenever possible, all drainage systems shall be drained to the public sewer or private waste disposal system by gravity. Horizontal drainage piping up to 75 millimeters in diameter shall be installed with a fall of not less than 20 millimeters per meter, and for larger than 75 millimeter diameter, the fall shall not be less than 10 millimeters per meter. It is a good policy to design the system for the highest possible velocity. However, consideration should be given to the fact that high velocities in pipes with slopes greater than 20 millimeter per meter may cause self-siphoning of the trap seal. So when we read this section, the code user must be understanding of the fall regarding certain piping. Even at higher velocities, if we carry solids within the system that are suspended within our drainage piping, we need to make sure that the solids do not drop out of suspension due to the steep slopes that one may think is better in a drainage system, because the solids will drop out of suspension and cause blockages. The code user, here's a note. Section 6.7 references Table 8.6.2 that provides minimum internal diameters of soil and waste outlets for specific fixtures. As we look at the horizontal drains, according to our graphic below, we have a 32 millimeter horizontal drain pipe for a wash basin. A fall of not less than 20 millimeters per meter is required. When we move to the right-hand side, we have a 100 millimeter horizontal drain pipe for a slop sink. We have a fall not less than 10 millimeter per meter regarding the larger pipe size. Section 6.8.1, Hangers and Supports. The piping, fixtures, and equipment used for plumbing, water supply, and drainage systems shall be provided with hangers and supports in accordance with Section 5.17 in Chapter 5. There are many variables to consider during the design and installation of hangers and supports. Consideration must be given to the type and size of the pipe material, the weight of the pipe, the fittings, and the contents being conveyed through the piping system. The structural element available for attachment must be considered. Any earthquake motions, vibration-sensitive applications, and thermal expansion and contraction must also be considered in the design regarding hangers and supports for our piping systems. The piping system shall be installed with proper hangers and support to minimize undue strains and stresses on the piping system or even adjacent building parts of the structure. All fixtures and fittings shall be provided with hangers and support to secure them properly. This section sends the code user to Section 5.17 in Chapter 5 for piping hangers and support requirements. Referencing Section 5.17 in Chapter 5 for piping hangers and support requirements, Section 5.17.1, Galvanic Action. We need to make sure that we do not have dissimilar metals in contact with one another. If we do, that may provide and even promote galvanic action. Section 5.17.2, Hanger Spacing. Vertical and horizontal piping shall be supported in accordance with Table 8.5.14. As an example, the picture below indicates piping being supported from the building's structure by means of a threaded rod and a hanger that goes around the pipe that we know as a teardrop hanger. Table 8.5.14, hanger spacing, gives us the piping material in the first column, the maximum horizontal spacing in meters in the second column, and the maximum vertical spacing in meters in the last column. According to the drawing below, the maximum horizontal spacing. If we have galvanized steel pipe to be supported, we need to enter the table's piping material. Galvanized steel pipe, in the application as indicated in the drawing, we want to know the maximum horizontal spacing for galvanized steel pipe. And by applying the table, we can see that the maximum horizontal spacing for this particular material, galvanized steel pipe, is 3.5 meters. For the PVC pipe that is indicated in the drawing, the maximum horizontal spacing between hangers for PVC pipe is 1 meter. Section 6.9 gives us design considerations. Some general requirements are given to us in our code. Section 6.9.1, titled Objective. For the design of drainage and sanitation system of different buildings according to building classification, the objective shall be to safeguard against fouling, deposition of solids, and clogging, and with adequate cleanouts and inspection chambers so arranged that the drains may be readily cleaned without risk of health hazard. The sanitary drainage system of the building and premises must be designed in such a way as to allow for flow of waste through adequately sized piping that will not impede the flow of the drains. This involves joints, fittings that not only direct the drainage flow, but will also improve periodic maintenance, such as drain cleaning and rodding. Section 6.9.2 gives us general requirements. Item A indicates the plumbing system shall be designed and adjusted to use the minimum quantity of water consistent with proper performance and cleaning. Item B, plumbing fixtures, devices, and appurtenances shall be supplied with required volume of water at pressures adequate to enable these to function properly and without undue noise under normal conditions of use. As seen below, we have a bathtub type fixture here that has a water supply, both cold water and hot water supply to it, and the drain of the fixture shall be functioning properly as adequate with the volume of water and pressures to that particular fixture. The water closet, the European type water closet shown below, has a tank that is filled with water and a flushing lever that, when actuated, evacuates the bowl accordingly. Again, the required volume and pressures must be according to the manufacturer for this particular fixture to function adequately under normal conditions of use. Section 6.9, Design Considerations. We need to specifically understand certain designs the requirements that go into designing and constructing the plumbing sanitary drainage system. Section 6.9.3 gives us different building drainage systems. The requirement here is as follows. For the design and installation for drainage piping, one of the following building drainage systems shall be adopted. 1. The single stack system. 2. The one pipe system. And 3. The two pipe system. Figure 8.6.1 gives us an illustration of the single stack system, which we will describe systematically. Figure 8.6.2 gives us a diagram of the one pipe system. And finally, figure 8.6.3 indicates a diagram of the two pipe system. Looking at these briefly, in summary, we can go back to the single stack system and observe that it is a single pipe with connections made directly to that single pipe, which serves both as a discharge means for horizontal connections and a main artery for venting or providing atmospheric air pressure into this system. The diagram of the one pipe system is illustrated accordingly, where we have a soil stack indicated on the right-hand side and individual vents that connect fixtures that tie into the soil stack horizontally. All of the venting ties into branch vents which run horizontally and connect into the vent stack. The diagram of the two-pipe system, by inspection, can be looked at as separate systems. However, they are interconnected with respect to the venting. On the far right-hand side of the two-pipe system, we can see a soil stack that receives the discharge from water closets on each and every floor level. That is an isolated stack for the water closets. The next stack is the wastewater stack in the middle that collects discharge from wash basins, sinks, bathtubs. As you can see, there are no water closets or urinals on this particular wastewater stack. In both cases, the venting is interconnected through individual vents and branch vents and ultimately connected to the vent stack, which is seen on the left-hand side of this diagram. To further understand our piping systems, we will go into further detail. Section 6.9.3, item A, indicates the following. Single stack system may be used with 100 millimeter diameter stack for buildings up to 5-story height. The fixtures in each floor shall be connected to a single stack for increasing the rate of discharge in the downward direction. So right here is the requirement and limitation for this particular type of piping system. This system is allowed for up to 5-story height, and it may be used with a 100 millimeter diameter stack. The recommended depth of water seal trap for the different fixtures shall be in accordance with Table 8.6.4. When we reference that table below, we will see that the fixtures are indicated on the left-hand side of the table, and the water seal requirements in millimeters are indicated on the right side. As an example, floor traps, the fixture that we call a floor trap, maybe a floor drain, must have a minimum water seal of 50 millimeters. Below the table is an explanation of a trap and where the seal is located for a trap. We have the inlet that comes in from the fixture, discharging into the trap. As it discharges through the trap and goes up above the dip, as can be seen here, and then spills over into the weir, which directs it to the outlet. That distance from the top of the dip to the weir is what we call the seal. This is the vertical elevation that we need to maintain according to the table above. So if this trap was for a floor drain, we would have to make a distance, which we call a seal, of 50 millimeters. This was filled with water to protect the occupants of the building from any type of noxious odors and sewer gas migrating back into the building. And that is the function of our traps. We provide a water seal as a barrier to prevent these gases from entering our homes and buildings accordingly. As we continue our discussion regarding the single stack system, there shall be at least 200 millimeters vertical distance between the waste branch and the soil branch connection, while the soil pipe will be connected to the stack above the waste pipe. The size of the soil branch shall not be less than 100 millimeters. The horizontal branch distance for fixtures from stack and bends at the foot of the stack to avoid back pressure, as well as the vertical distance between the lowest connection and the invert of drain, shall be as shown in figure 8.6.1. As we can see, according to that figure, we have, in fact, the distances indicated as such. We have the 200 millimeter distance indicated under the bathtub. As you can see, we have a 50 millimeter diameter parallel branch introduced if the bath waste would otherwise enter the soil stack below the water closet. And we have our 200 millimeter distance. That being shown, the size of the soil branch, not less than 100 millimeters. As we can see, up at the top of the stack, this is a full 100 millimeter stack accordingly. The next section is section 6.9.3, item B, describing the one-pipe system. Where all types of waste from the building are desired to be discharged into a common sewer or into the same waste disposal system, a one-pipe system may be used. Figure 8.6.2 gives us a description of what this may look like. As you can see, we have 3 different floor levels. This is our diagram of the one-pipe system. Observe that the sink, bath, and wash basin fixtures are connected to the branch waste pipe and each fixture is individually vented. Also observe that the water closets are connected directly to the soil stack by branch soil pipes. The water closets are individually vented as well. All branch vents are graded properly and connect into the vent stack at each floor level. As we can see, we have what's called the branch waste pipe that carries the waste from the sink, the bath, and the wash basin directly into the soil stack. The water closets are tied in or connected to the soil stack as well. We have individual vents off of each and every fixture. However, they are connected by means of what we call a branch vent that runs horizontally and connects into the vertical vent stack accordingly. This gives us a good, well-rounded one-pipe system that is properly piped in as far as the drainage goes and the vent to allow proper air into the system when designed properly. Section 6.9.3, Item C. This is the two-pipe system, where the sullage from kitchen and bath will be dealt with separately, and where soil waste shall be discharged into septic tank or Imhoff tank, the two-pipe system shall be used. Figure 8.6.3 gives us the diagram. In this diagram, observe that the sink, bath, and wash basin fixtures are connected to a dedicated wastewater stack, and each fixture is individually vented. When we look at the diagram, again, we see that we have a separate soil stack that serves as the vertical discharge for water closets and urinals on different floor levels. The wastewater stack, indicated in the middle, receives the discharge through the horizontal branch from fixtures like the sink, bath, and wash basin accordingly. Observe that the water closets and urinal are connected to the dedicated soil stack again. Additionally, all the branch vents are graded properly, and they are connected into the main artery for air that we call the vent stack. Section 6.9.5.2 gives us a requirement regarding the slope of horizontal drainage piping. Whenever possible, all drainage systems shall be drained to the public sewer or private waste disposal system by gravity. Horizontal drainage piping up to 75 millimeters in diameter shall be installed with a fall of not less than 20 millimeters per meter, and for larger than 75 millimeter diameter, the fall shall not be less than 10 millimeters per meter. It is a good policy to design the system for the highest possible velocity. However, consideration should be given to the fact that high velocities in pipes with slopes greater than 20 millimeter per meter may cause self-siphoning of the trap seal. So when we read this section, the code user must be understanding of the fall regarding certain piping. Even at higher velocities, if we carry solids within the system that are suspended within our drainage piping, we need to make sure that the solids do not drop out of suspension due to the steep slopes that one may think is better in a drainage system because the solids will drop out of suspension and cause blockages. The code user, here's a note. Section 6.7 references Table 8.6.2 that provides minimum internal diameters of soil and waste outlets for specific fixtures. As we look at the horizontal drains, according to our graphic below, we have a 32 millimeter horizontal drain pipe for a wash basin. A fall of not less than 20 millimeters per meter is required. When we move to the right-hand side, we have a 100 millimeter horizontal drain pipe for a slop sink. We have a fall not less than 10 millimeter per meter regarding the larger pipe size. This is the end of the presentation. Thank you for your participation.